All right, so we factored that. Nothing cancels out, so there's no holes. Let's talk about your vertical asymptotes. Remember, that looks like a down arrow, so you go below the fraction bar. So I know x cannot equal a -1. That is the vertical asymptote. So let's write x equals -1. That is all to the first power. The first power is odd, which means opposite behavior for the vertical asymptote. Very good. Very important. The most important thing is that right there. All right. So remember, OH, that's where the fight happens. So they're battling for power. They're battling for degrees. So if you look over here, where are most of the degrees? Top, bottom, or equal? Top. All right. So when it's at the top, there's no horizontal asymptote. So I'm going to go over here and write none. However, there might be an oblique. And there will be an oblique as long as the top is higher by 1 degree, which it is. So the way that we're going to find the oblique just means a slanted line. We're going to have a slanted line on our paper. The way that you find the oblique is to divide. Remember, this is a fraction. We're going to divide it. So I'm going to use the original problem because it's easier for me to divide when it's not in factored form. Remember, what's on top goes inside the box. So I'm going to write x squared minus 2x and then x plus 1 on the outside and just divide. So I want x to look like x squared. I just multiply it by an x. Keep all my linear terms together. X times x is x squared. X times 1 is a positive 1x. Don't forget to change the signs and subtract. So let's change these signs. X squareds cancel out. And then, y'all, that -2x and -1x is now -3x. I don't have anything to bring down. But, y'all, I can still make x look like that. What would I multiply that x by to make it look like that? Exactly. So write -3 up there. So -3 times x, -3x. -3 times a1 is -3. And then when you change the signs, I don't even care about the remainder. The remainder is 3. But the oblique asymptote is the quotient. So y'all, we're going to have a line at y equals x minus 3. So on the oblique asymptote line, write y equals x minus 3. And guys, if you have a highlighter or something, remind yourself, because that's going to be really easy to forget. This is how I find oblique. And remember, why did we even try to find the oblique? Because the numerator won the degree fight. Okay, so we're done with the fight, the O and the H. Now we go to the zeros. The zeros are just the top. You have 2 x-intercepts, y'all. What are the x-intercepts? Good. 0, 0, and then positive 2. So let's write those down. And they're both to the first power, so I'm going to write an S to remind myself that x-intercepts have the behavior of straight through. That's the only piece of this that's related to polynomials. Is that right there? All right, now let's talk about the y-intercept. So remember, for the y-intercept, x equals 0, so we're going to plug in x. Oh, I already have the y-intercept. Remember, when it goes to the origin, it's the y-intercept at the same time. All right, that's it. We now have everything to graph. So let's go ahead and start graphing, guys. All right. So I'm going to go ahead and plot these x-intercepts. They both have straight behavior. I'm going to say the 2 is pretty far over. Again, guys, I spread this stuff out because otherwise I kind of get tripped up on how they are supposed to look. So use your space on these sketches. Vertical asymptote, we only have 1 at x minus 1. I'm going to say it's right here. And then what do you have to write under there? Op. Okay, so listen. The oblique asymptote is just y equals x minus 3. Guys, when I graph that, where's the y-intercept? Or no, for just that line. Where's the y-intercept for that line? -3. Remember, that's the y-intercept for that line. So, like, it's going to start down here. Just put a dashed line for right now. I know my slope is positive because it's up 1 over 1. It's just an x. But the reason why I want to hold off for a moment is because I don't know if it goes through these points or like if it goes that way. So let's figure it out. So remember, you have an x-intercept at 2. Y'all, if I plug a 2 in right there, what's 2 minus 3? That means that this is below that x-intercept because we got a -1 for the y-coordinate. So when you draw this dashed oblique asymptote, make sure that it is below both of your x-intercepts. Yes, ma'am? Yes. So since we don't have tick marks where I can like count and draw my slope to make that line, I just really want to figure out where it is in relation to these two. I know it's below that because the x-intercept's way, or the y-intercept's way down there. I don't really know about that, so I plugged in 2 right there. And since I got a -1, I know it's below that.
If there's a positive, it would go above.
Yeah, then it would be like in between them. All right, so that's it. That's all the information we have. And guys, I'm going to go over here and use this little tool for a moment because this is not right. I'm going to show you something that's wrong. So I know I have a graph that goes in between stuff. Guys, if I try to do this, I would be running into asymptotes and then just get stuck. So I know it cannot open down. So if it cannot open down, then it's going to open up. And remember, it's going to hug all of these red lines. They're going to hug these asymptotes. So it's going to be, the graph is going to start way over there, just as close as you can. Hug that asymptote until you see the door. The door is the x-intercept. You have to go through the door. All right, so now I'm down there. I see another door. I got to go through it. And then when I go through the door, oh, there's another asymptote. I love asymptotes. You're going to hug that slanted line as best you can. And then as soon as you lift up your pen or pencil, you better go to that vertical asymptote. So here's the vertical asymptote. Remember, we wrote opposite. We drew an up arrow by it. So over there on the left side, we have to draw a down arrow. And the down arrows go next to the down arrow. So if it's down arrow, you're going to have a little baby branch right here that does nothing but hug the asymptotes. And that's that one.